All right, so the first part of the video is 1 through 7. So I'm starting here with number 8. We got a public swimming pool. We got 2 laundry detergents, A and B. We're going to clean the towels that are used every day. As each dirty towel is turned in, it's placed into the only washing machines. When it contains 20, we flip a coin to see whether they're going to use detergent A or detergent B. So that's random right there. The cleanliness is rated. We don't know which detergent was used, so that means it's blind. That's good. The manager does this a lot, which best describes. Okay. It's not observational because we're controlling who gets what. It's not matched pairs so it's not block because we didn't split it into subgroups. We didn't say like male laundry is one subgroup, we'll test A and B on, and female laundry is another subgroup, we'll test A and B on, for example. Matched pairs we haven't really talked about yet, but that's like a block with subgroups of size 2. So this is not that either. This is completely randomized because every load of 20 that goes in, you're just flipping a coin and it randomly gets one thing or the other. So number 9, matched pairs. So we haven't gotten into t-test yet, but basically for now you could just read this question as matched pairs is not appropriate for which of the following. So matched pairs is a specific type of block where every block is size 2. So it could be like my right hand and my left hand. Like I've got 2 index fingers. This one, I'm going to try something that makes my, fingernails stay cleaner. And this one, I'm going to try doing nothing and see which one does better. And then I'll have like 100 different people do that. And that way, the control and the test are as similar to themselves as they possibly could be. So that's what we're going for in number 9. The control and the test to be their own pair as similar to themselves as they possibly could be. So look, if you look at A, so this would be a measurement of annual income before and after. So you'd be your own control group there before you took the course, and after took the course, you'd compare. So what's the most similar to me is me. Well, I'm going to look at me before the course, me after the course, see if the course changed anything. And I have my own matched pair there. Select the pairs of twins. That's certainly a subgroup of 2 that is similar. Measurements of income formed by matching 100 people in state A and B based on education. So what they're doing is making similar pairs based on education. That is matched pairs. And then we can say like, maybe the course helps people with low education but not high education, for example. D is not matched pairs because we're assigning people to pairs at random instead of by some important subgroup scenario. Number 10, they give you this idea that we're going to practice multiplication with a flashcard or on a computer. So they are going to block on gender because they think gender might matter. So what that means is we're going to do one experiment for males and another for females. So males, we're going to go flashcard, computer. And females, we're going to go flashcard, computer. So 2 subgroups, 2 experiments. Double blind would mean the person running the experiment doesn't know what the student is doing, and which is possible. Like you could kind of just tell them to go in this room and do what's in there, and you don't really know what's in there. But double blind would be this person doing the experiment doesn't know either. And since we're trying to test what's better, flashcards or computer, it's impossible for the student to not know if they're using flashcards or a computer. So it can't be double blind in that scenario. Number 11. George and Michelle both bake cookies. George asks a random sample of his friends to taste his cookies and complete a questionnaire. Michelle asks her friends, which are different people, to complete the same questionnaire, and then they compared results. So A, different group of friends, definitely different to compare recipes, yes. B, because they used only their own recipes, their cooking ability is confounded with recipe quality. Yeah, George just might have a better recipe or something. C, recipe quality is confounded with characteristics of the oven. Yeah, Michelle might have some kick-butt oven, and George is 30 years old and barely works. E is false also. There is no replication. I'm sorry. E is actually true. which makes it not the correct answer. There is no replication because they both only baked one batch. And D is false, which in this case makes it correct. So if I only asked George's friends a question, I can only generalize that result to George's friends. I can't generalize it to Michelle's friends. There could be something different about George and Michelle that make their friends very different in some way. 12, we got rubber bands. Box A, box B. We want to test the elasticity, so we're worried about elasticity. For some fun reason, we're going to put 10 bands of brand A in a freezer, and the 10 bands from box B are kept at room temperature. So now, let's say that box B, or box A, let's say box A breaks way faster. We have no idea why. We don't know if it's because brand A rubber bands or because they were frozen. So that temperature thing, like putting everything in the freezer, just messes things up. It confounds things. It's another variable. So it's not a good experimental design because I don't know why the heck you would put some of them in the freezer and some not in the freezer, unless you're trying to test something about the freezer. 13, so contact lens wearers. We're going to try a new eye drop solution. We got 25 volunteers. They're going to use the solution for a month. At the end of the month, 36% of people said the new solution was effective in relieving dryness. The company then claims their solution is better than not using any solution at all. That is not supported because we didn't use a control group. It's possible that 36% of the volunteers' eyes would have gotten better regardless. I mean, it's been a month, so maybe your dry eye situation went away. So unless we can say, yeah, here's what happens if you take eye drops, here's what happens if you don't, here's the difference, that it's not a, you cannot make that conclusion. Yeah, it's not an experiment, right? We didn't control who did what because everyone did the same thing. 14, Mr. Eichler. Investigating a new method for teaching mathematics. So there's a new method and a traditional method. Both groups taught by the same teacher. That's good because then the teacher is not a confounding variable. It's not like a different thing that's in the mix. And it's the same in both groups. At the end of the unit, a test was administered and we're going to make a comparison. What's the response variable? So the response variable is what we're trying to measure, what we think the outcome is. And we're trying to measure the effectiveness of the teaching. So it should be something about measuring what you know. So the score of the achievement test. So how we do in the achievement test, that's how we're going to measure whether the new teaching or the traditional method was better. I'm going to stop there for now.